Greetings, this is Miss Jackson. This video is going to cover the page 84 extra practice. For this page, we're going to be covering how to build fractions that have a value less than a whole. So problem 1 has a lot of parts to it. It first says complete the number sentence. So let's start with that first part. The number sentence is found right here. How it's written right now is known as unit form. It's written with a number and then a word, 2/5. We need to turn that into fraction form, which is just a normal standard fraction, 2/5. The second part of this says estimate to partition the strip equally. So right here is the math model that we're going to be using. It is like a long strip diagram, which we have studied since the beginning of the year. This strip altogether represents one whole. We now need to decompose this into the fraction here. When you're looking at a fraction, there are two parts to it. There's the numerator in the top, and there's the denominator in the bottom. The denominator is going to tell us how many sections we need. How many parts is this whole thing broken into? In this case, there are 5 parts. So we're going to kind of estimate to make 5 sections. To do that, we're going to need 4 vertical lines. Because this whole thing represents one whole, when we break it down, we're breaking it down into parts smaller than 1. We're breaking it down into fractions. We need to go ahead, and the next step here is to write the unit fraction inside each unit. We want to write the value of each unit. Labeling fraction models in my class is really non-negotiable. It is not an option. You need to label the model. So this little section right here has a value of 1/5. That is 1/5 of the whole model. This section also has a value of 1/5. Each of these sections are going to have a value of 1/5. They occupy 1/5 of the shape. After that, it says shade the answer. I should have used a highlighter there. I meant to use a highlighter there. Let's pretend I used a highlighter. Oh, come here, you. Shade the answer. And I'm going to shade it with my highlighter. So what we want to shade is 2/5. This top number is the numerator. And I always say that is the part that is being asked for. In this case, it's the part that they tell us is shaded. So we're going to shade 2 sections of it. From there, and here's the last part, and the wording is very, we'll say fancy sounding. It says, I feel like this deserves its own color. Then write the fraction as a sum of unit fractions. And that sounds very complicated, but it really isn't. There's some keywords to help guide us here. The first is sum. When we have the word sum, we know that we're working with addition. And then the next is unit fractions. A unit fraction is any fraction with a 1 in the numerator. It's one part of a whole. So to create an addition sentence, and that's what we're doing here, we are going to have 1/5 plus 1/5. Those are my 2 unit fractions, is equivalent to 2/5. All we did was take these 2 parts and write them into an addition sentence. Problem 2. A. What fraction of the circle is shaded? So the first thing we want to do is we want to make sure we know how many total pieces there are so that we can set our denominator. I see 1, 2, 3, 4, 5, 6, 7, 8. And how many of them are shaded? I see one piece here that's shaded. 1/8 is shaded. Now, I like for kids to go through and label their pieces with the value of each section. And now we can answer the second part, which says, what fraction of the circle is not shaded? And this has been kind of the hiccup this week. So often kids are asked to find or represent the shaded part of a whole or the shaded part of a shape. And it's hard for them to start thinking about, sometimes they're not asked that. Sometimes they're asked what part is not shaded. And in this case, we would need to go add up how many pieces are not shaded. There are, and I'll use a highlighter for this, 1, 2, 3, 4, 5, 6, 7. 7 parts are not shaded. 7, remember that I said the top is the numerator. That's what they're asking for. 7/8. The denominator does not change. The denominator is always the total number of parts it takes to create this whole or this figure or shape. That is not going to change. What might change is going to be the top. Lastly, number 3, complete the chart. And part of this is pretty simple. Total number of equal parts. Well, this shape there are 4 equal parts. Total number of shaded equal parts, 1, 2. The unit fraction. And what they mean here is what is the value of each little section on its own. The unit fraction would be 1/4. And then the fraction shaded there is 1/4 here, another fourth there. That would be 2/4 is shaded. Okay, that is it for problem 84. If you notice your child is still struggling with fractions and identifying not just the shaded parts, but also the unshaded, I would suggest drawing figures, dividing it out into as equal sized pieces as you can, because for us to be able to work with these fractions in 3rd grade, they must be divided in an equal way, and just keep practicing with them. How many pieces are there that make the whole? And that is your denominator, the number in the bottom. And then how many pieces are being asked for, either whether that's shaded or unshaded on this page. Later we'll start to see what it looks like in word problems, because of course we are never given something as simple as problem 2. Everything is contained within a word problem. Right now we're just building skills to be able to tackle big word problems later. Okay, that is it for this video. If you have any questions, please feel free to reach out. Thank you.